Welcome to the Synthetic Biology panel at BioImpact. This conference does not always bring together many people from synthetic biology world or SynBio. And that's why we wanted to put this panel together to get a better understanding of what's going on in the sector and to bust some myths. So welcome to Synthetic Biology, Fact or Fiction. I'm Kathryn Sheridan from Sustainability Consult, and my work is all about credibility around sustainability and around biotech. So I look forward to hearing from our speakers with that lens of credibility on as always. So please welcome Jim Lalonde from Inscripta, Zach Serber from Zymergen, Matt Lipscomb from DMC Bio, and Martha Maripes from Wiley Law Firm. Welcome.
Thank you.
So before we dig in, I want to make sure that we're all on the same page, and if we're not, that we understand the differences. So do you each have a short definition of SynBio or synthetic biology? What is it to you?
Maybe I can go first. So I just would say it's the application of engineering principles to biology to make or to use the tools of biology to make things that biology normally would not do, either in a manner it would not do or a material that it would not make.
Who else wants to come in?
I like Jim's explanation. I was going to say something to the effect that is about applying engineering principles to biology as well. And the inclusion of having biology do something above and beyond what it ordinarily does, at least in that system, I think is also a nice add-on.
Matt, what would you add?
I also agree. I think I like that definition, though I would add a theme of economics to it, right? So I think unlike pharmaceuticals, when we talk about industrial biotech, I think we're often talking about making a material or a product at a particular price point at which a customer is willing to pay for it. And so I think having an economic angle on the discussion as well makes a difference.
And Martha, I'm sure I'm going to keep coming to you for the regulatory perspective. That's your expertise. Do you have anything to add to the definition?
Sure. Well, I see synthetic biology on the frontier of biotechnology. It's constantly changing. It's a collective. It's an enabling platform. There's so many different, directions in which it's going. So it's very dynamic.
Okay, well, it seems like we're more or less in agreement. So that's a good start to our panel. We don't have to spend a lot of time examining all the little differences and splitting hairs. But let's look at the next question that I have for you. How do you define success? We might all agree with what synthetic biology is, but what does success look like? This is a very varied industry. There are some massive success stories around fundraising, commercial successes. Or is it something simpler about sustainability or reducing carbon emissions? So I'd love to hear from you how you define success.
Yeah, well, for me, from where I sit in a regulatory setting, it's helping my clients get through really the last gate, legal gate before commercialization, which is the regulatory gate. A lot of startups are very intent early on, getting their IP in place, and of course their funding, as you said. Each of those is a step of success along the way. But once they pass the regulatory gate, then you can go commercial, and that's in what I do the ultimate success.
So by the time you get your hands on it, Martha, it's pretty much going to market.
Hopefully. Yes, it has to work for sure. And sometimes it's an interesting dynamic of getting an approval for something that's still in the development and really always will be fine-tuned. But absolutely, it's, at the point that I see it, a lot of times I'm seeing commercial platforms that have had some level of success in the R&D stage.
Yeah, so for you, it's around market access, regulatory approval for things to be allowed to go onto the market. We have some probably different perspectives from the companies. So what does success look like to you, Jim?
I would say if it's commercially applied and it's displacing something, those are two great measures of success. And then, if you recover your investment, which is really tough to do, but especially if you're one of those first products. But I like what Pat Brown said there. You know, the mission of Impossible Foods is to shut down economics for animal husbandry. You know, which is a huge measure of success. But so I go to commercial and then recovery of investment. Those two things.
It sounds like a huge ask. It sounds a bit like a moonshot, you know, to actually shut down an entire sector of the economy with a huge lobby behind it and a lot of power.
Yeah, that would be a huge success. But obviously, we've had some smaller ones. Like for instance, you know, enzymes in detergents. 20 years of DuPont, Jennings-Core, Novozymes using protein engineering to come up with new products. So.
And so in that case, it's an example of displacing something.
Yeah, or improving, you know, what nature has given us in terms of natural enzymes from bacteria in this case that are secreted by, say, Bacillus subtilis, to engineer to be stable in a laundry machine, which is something nature never anticipated.
Right, exactly. Yeah. And recovering the investment, as you said, that's tough to do. I think we'll probably come on to talk more about the economics, but did you want to say anything already now about that?
Yeah, I mean, there's a lot of path. A lot of people were cutting trail for us where they'll never recover the investments, you know, like Jennings-Core again, you know, for isoprene and indigo. They had teams of 20, 30, 40 people working on those projects, you know, 15, 20 years ago, and that money is gone. But, you know, those are examples.
I think recovering your investment is an understandable metric that we might hold ourselves to, but it seems like an awfully low bar. And if all we can hope to do is recover our investment, we're not going to fulfill the promise of the bioeconomy. And I think the audience at Bio will appreciate that there's a huge potential around biology becoming a huge economic factor in the 21st century. And I think everyone on this panel would agree that synthetic biology is part of the key to unlock that potential, to have bio-based technologies relevant to more of the economy above and beyond where it has historically played, which is chiefly in therapeutics and in agriculture, with some also in consumer care, with enzymes, for example, for cold water tide. But the potential is far vaster. And with the examples you raised, Jim, of projects that never recovered, one of the commonalities with them is that they were drop-in replacements. They were seeking to make molecules via biology that otherwise are made industrially. And I think that that is both a source of trouble and a huge opportunity for the sector, that we ought to be focusing our efforts on fulfilling unmet market needs. And the measure of success is the ability to solve real-world problems with biology that have foiled the attempts of other technologies to solve them previously, or that where the solution is in many ways massively suboptimal. This can include sustainability, but ought to also include other dimensions of success, performance features above and beyond sustainability that make the public and the consumer flock to that solution because of the virtues it provides above and beyond sustainability. There will always be a cadre of the economy, the consumer, that will buy based on sustainability concerns, and I fervently hope that that segment of the sector of the economy is growing. I think it is, but a much more robust source of long-term economic traction is offering solutions that are virtuous above and beyond sustainability, and that often means venturing into product solution areas that aren't precedented already in other industries. So it requires a bit of boldness on product development.
I've always thought that the holy trinity for the bioeconomy is performance, price, and then sustainability. It's like the sustainability has to be taken for granted. It has to be a part of the offering. You know, it's not the main selling point. And I think that might be where we went wrong in the early days of biomaterials, because we actually thought that sustainability would do it. You know, the companies would be biting companies' hands off to get products that just happen to be made with biotech and were more sustainable, without taking into account that you need to have at least as good performance, but very likely better performance. Matt, I'd love to come to you on the idea of your definition of success, and then there's some other points I'd like to pick back up on.
Sure. I think I would echo a lot of what has already been said. I think ultimately it's around business success, right? It's how can you get a product into a customer's hand that's willing to pay for it at the price that you can sell it and be profitable? I think the elements that Zach and Jim touched on are important too. So obviously in a new industry, we're reliant on investor funding to make that happen. And the investors not only want to get their money back, but they want to make a return on their investment. So how do you do that in a way that's where everybody wins, where the customer or the marketplace wins because you're providing a product that provides some enhanced value above what is currently out there, whether that's in the case of a new material or new molecular entity that provides some new function that's uniquely enabled by biology, or whether it's by improving efficiencies of something that's incumbent, whether that's an incumbent-based manufacturing route from petroleum, whether it's from an extractive-based process, or even whether it's from what is at this point perhaps an antiquated bio-based process. I mean, as Jim sort of noted, there are some processes out there that are now 20, 30, 40 years old. So there are opportunities even for things that exist to do better, if you will. So more efficient, more sustainable, and ultimately at a better price point. So I think there are different value buckets, and it's how do you get all of those aligned, or enough of them aligned, that the customer is willing to pay for it at a price at which you can be profitable as a company.
Yeah, you touched on the investors wanting to get a return, and usually relatively quickly. Does that stifle the development in a company? Does that put an unnecessary pressure, or does it affect your creativity? Because it's been mentioned that you have to be bold in product development, and it feels like to be bold, you need to have a certain amount of a margin to play in to be able to be bold. And if you've got investors breathing down your neck, like how does that play out?
You have to be incredibly thoughtful about choosing the unmet market need you're going to seek to solve. If you choose poorly, you may have technical success, manufacturing success, but lack commercial success, or your timelines may be too long to fulfill the needs of your investors. So at my company, at Zymergen, we have one area we've focused on is consumer electronics, which is a peculiar place for bio perhaps to be participating historically, but it is an area where materials innovation means the difference between winning in the market and losing. If you have the right materials embedded in your device that confer advantage properties, you can take market share. And the cycle of innovation is incredibly rapid. So it puts some tremendous pressure on the biology side to keep up with that pace of innovation, to anticipate what the needs are going to be, and to offer solutions from biology that can't be arrived at by some other means. And if you can do all that, then the payback period is actually quite rapid. The regulatory hurdles are rather low as compared to other sectors where biology, like ag and therapeutics, where we traditionally play. And the speed of uptake can be astonishingly fast. So it can have attractive payback periods if chosen wisely.
Yeah, what's interesting about electronics and sort of stuff that people buy in general is there's a lot of pressure on those companies, and they are starting to step up to try to make their products more sustainable. It's just such an obvious application, the smartphone, the laptop, or whatever. Could you give us an example of what type of materials, just in what kind of function your material would be used in an electronic device of some sort?
Absolutely. And while sustainability is a component, as you mentioned before, it's third on the list in that the chief virtue we offer is one of performance. So there are famous polyimide films, which were first developed by companies like DuPont back in the 60s, which are incredibly temperature resistant, thin, have a lot of wonderful thermal and mechanical properties, but they they're always orange in color. They don't have favorable optical properties. And we were able, by employing monomers available from biology and very hard to arrive at through other means, a set of monomers that retain the attractive thermal, mechanical properties of the polyimide films, but were optically transparent. And they set the stage for flexible electronics, a new generation of materials that will be embedded in not just bendable, but also truly deformable electronics that can assume any shape. And with that flexibility, you open up new product classes. And yes, of course, something like a Galaxy Fold is the first dipping one's toes in the water of truly flexible electronics. But as you may know, the development of that phone was delayed many years with many false starts, almost entirely due to challenges they faced on the material sciences side. With the incorporation of biomonomers, you are basically embarking on materials science with a whole new palette of starting chemicals, starting ingredients, which are quite distinct and differentiated from the classical petroleum building blocks that people have used before. And with that expanded palette of chemicals, you can create a variety of new exciting materials. We have chosen polyimide films as our first venture, as our first commercial product, because it's such an urgent unmet market need with such potential for rapid growth. And it was a place where biology could offer a solution that couldn't be had by any other means.
That's really interesting. I'm sure the audience will find like the real life examples also very relevant. Jim, I'm wondering from the Inscriptor perspective, where are you on success? What does success look like? What's a commercial success for you?
Yeah, no, I mean, tying that back to your question on investors, I think investors have been relatively patient and helped us develop tools like, NGS, next-gen sequencing, and now with Inscripta doing sort of automated CRISPR genome engineering. They've been relatively generous, and those tools that we've created have gotten better and better and really have enabled us to take, what might have taken 50 people, like I give some examples of early programs at Genicor, to now you'd have a few scientists, a few months doing the same sorts of projects with a greater level of success. So I think tools construction is really, or creation is a huge element that investors have helped us enable.
Okay, thank you. Matt, what does it look like from the DMC Bio perspective, your take on success in the industry?
Sure. We've taken a little bit of a different approach in that we are targeting products that exist today in the marketplace, not necessarily those that are derived from petroleum. So we are going after things that are more bio-based today, but as I said before, perhaps are more antiquated, and there's opportunity there. So we recognize that it's a real challenge and a real hurdle to do not only technology development, but in many cases the market development for new opportunities. So we're intentionally saving those for the portfolio, and we have a lot of things on tap. But we're starting with things that exist and trying to get to cash flow positive sooner rather than later. Thinking that success will beget success in that case. So.
Okay, thank you, Martha. Do you want to chip in anything on the success question, or shall I keep moving?
Well, I would say one of the last things you want to tell your investors, if you've put in all this, time and effort into develop a commercial product, is that there's delays at the end of the process because of regulatory issues. So just take those into account. Choose your markets wisely. A phased approach, for example, might be in order if you're trying to go for the gold standard with an unmet and very, very innovative application that may take a little bit more time, for the regulators to approve. And so understanding the regulatory timeframes of your different applications really will help you in coming to market more predictably without that last minute hiccup on the regulatory side.
And I'm assuming that it's more complicated from a regulatory perspective when it is a novel material than when it is a drop-in.
Yeah, I mean, we've had people come to us, with amazing prion technology at the end of their investor funding and wanted to get approval as a pesticide. Well, that's, $2.5 million worth of data and, several years. So that's something to think about sooner rather than later, and maybe, again, pivot to these other markets that Zach was mentioning that have a lower regulatory hurdle in the meantime while you're, working your way toward that ultimate goal.
So like Matt said, always having things in the pipeline that are, once you've established some market space, then you come with your pipeline.
Yeah,
Okay.
It's important to build that, regulatory timeline into your pipeline, just to have that as one of your overlays in addition to everything else everybody's mentioned. It makes things go a lot smoother. Again, investors don't like, or, CEOs don't like surprises at the last minute.
Yeah. Yeah, that's interesting. And I'm sure that a lot of startups will be watching this, wanting to learn from the experts on the panel. I mean, Is there other words of advice that you could give them, Martha? Is it just to really factor in the regulatory soon enough, or is there a particular sort of milestone where you say they must already be considering it and talking to lawyers about it?
Again, choosing your markets wisely is really important, and understanding what you need to do to support your technology on the plant side and on the microbe side. Sometimes when you're going for that investor funding, one of the things I tell companies is set a little bit of that money aside for research and development. If you need to do any kind of toxicity testing or testing that the regulators would need to see, and I see more companies doing that. So that's one of the big factors is, again, just plan early and choose your markets wisely.
And start to get your papers in order earlier than you think, by the sounds of it.
It takes a long time. Yeah, maybe that's where you're going. Don't underestimate the time that regulatory takes to get done.
I've been in Brussels for 20 years, so I can only agree from the European side that it is kind of time consuming. Well, the title of this panel is SynBio, Fact or Fiction, and it would be remiss of me not to ask the question. Now, you all seem like very reasonable, very head screwed on right kind of business people in the sector. So I wonder what you're going to give me as an answer. I want to know, do you think that SynBio is a fact situation or a fiction situation? Is it all hype and smoke and mirrors, or is it actually all it's cracked up to be? And anybody that wants to go for this, please just start.
Yeah, sure. I mean, I would fall on the side of fact, but there is a lot of aspirational stuff that, we've yet to deliver on. There's a huge amount of investment. I think it took us 15, 20 years to nail, protein engineering, but I think we're there. It's going to take us a while to complete strain engineering. And I think we're on the right path, and I'm very optimistic, but we still have yet to deliver with the amount of investment that's been made up until now.
Okay, so fact, but acknowledging that there is a huge aspiration there, and in a way it's that aspiration that actually drives us as a sector. Zach, what would you say, fact or fiction?
It's unquestionably fact, though of course people can be forgiven for suspecting it might be fiction because of all the hype. And I've been part of the sector beginning in the biofuels and lived through that bubble and that bursting, and then tried to raise money for Zymergen in the wreckage left by the implosion of a lot of biofuels companies, in which investors wanted to have nothing to do with synthetic biology. They thought it was just a money-losing proposition. And here we are again, many years later, with a bunch of prominent companies making big promises. And I think the lessons learned from that first debacle are helping us, helping some of us, not all of us, make more reasonable projections as to what is possible. My company has kept a pretty low profile for a number of years because we wanted to talk about things after we had done them, not on the promise of doing them in the future. And so when we launched our first product this April, this flexible hyaline polyimide film for consumer electronics, no one much saw that coming. But we made the first announcement about it when it's actually on the market, when you can buy it. And I hope that there will be other companies that take that stance, that have to acknowledge that there is a lot of skepticism. And the surest way to turn around that skepticism is to show up with a product developed with your technology, with SynBio.
Matt, does it make it harder to raise money when there's all that hype and all that wreckage in the memory of the investors still?
So our field, sort of, industrial biotechnology, definitely doesn't have the best reputation, I would say. I think historically there's been a lot of over-promising and under-delivering, and we certainly could use some more success stories. So I think we're all, in that sense, we're all in the same boat, and I think we're all supportive and encouraging of each other to get those successes. And I would echo what Zach said in terms of, I think many of us were informed by our past experiences, and hopefully are now only making original mistakes in that sense. So informed by the lessons of the biofuels heyday or biochemicals heyday, and doing things differently, and ultimately what will hopefully be more successful at this point.
So where do you sit on the scale of fact and fiction?
I think it's definitely fact. I think there is a tendency to go a bit too hype-based, depending on which particular media outlet is covering it. But I think there's a lot of really good work going on, a lot of potential that we'll hopefully see come to fruition in the next couple of years here.
How do you keep your head straight with all of this hype? I mean, it must be tempting sometimes to hype up what you're doing to get the headline in the tech press or to attract the latest investment. How do you really stay grounded to cutting through the hype and not sort of playing into that?
Sorry, go ahead, Jim.
Oh, I was just saying it's important to stay optimistic and enthusiastic, but also have a skeptical eye, and and when you're evaluating technologies, dig in a little bit and see what's really behind there, because there's no when things are presented to the public, sometimes there's no context, right? The things are put on equal grounds. Something that's a huge impact with something that's a minor or maybe even sketchy proposition. So I think that's important.
And do you think that's the press that maybe not intentionally misrepresents the information, or is it the companies themselves that are selling the easy story, the hyped story to the press?
I think we're guilty of doing some of the hyping and not putting things in the right context for the press, and then they take it further. So yeah.
Well, actually, I think it's more of a problem of the companies take the value for granted. They know it, they see it, they're living it every day. And the real challenge is being able to communicate that to investors as well as the public in a way that brings meaning to the technology, to the value it's actually providing to people's lives. That's the I Am Bio, videos that the association is doing is really hitting on that need. So that you're balancing the hype and you're actually communicating the value of the technology to your everyday lives in terms of what it achieves, but also in terms of employment, supporting families, and the size of the bioeconomy today, and the tremendous growth potential it has.
So that's really socioeconomic benefits, jobs, agriculture.
And I was just guilty myself of hyping it up a little bit there.
Just a little bit, just a little bit. So I want to come back. How do you deal, because you guys just raised a ton more money, and how do you deal with, maybe the temptation to hype it a little?
I disagree. I mean, sure, there may be a little bit of a temptation, but it's quickly overwhelmed by one's view of the long game. I mean, it's a short-term win, medium-term to long-term loss to create a hype cycle. And you're going to have to live with the consequences if you overpromise and underdeliver. And as a founder of a company, you want to ensure the longevity of your company. You want to make it last, and you have to be patient and stick to your principles around generating true value and demonstrating that value. The sort of muted tones you're hearing from this panel should not underestimate the true potential of the technology. I mean, the technology has the power to revolutionize and change manufacturing across virtually every segment of society and of the economy. That's grand. That's very grand. What we need to do to bring that about, chiefly in my mind, is introduce a strong profit motive behind it, in that, I mean, if all we do is break even, no one's going to flock to this industry. We need to be successful enough, economically successful enough, so as to attract new entrants who are motivated by the prospect of becoming the next, or founding or launching the next great company that's going to have a huge impact on the world, economically, socially. And to do that, we need some proof points. So, I mean, Zymergen's goal is to become, as a sustainable company, but also to be not just economically sustainable, but economically very well off, because we have found the right combination of technology and markets and can provide a key proof point that are going to inspire others to take up the mantle of using biology to overturn or displace existing solutions. So the goal is very grand, but you're not going to get there by talking about it overly much. You need to do it by showing.
Yeah, well said.
Yeah, indeed. Matt, anything on this?
As an engineer by training, I don't have a hard time staying grounded in reality. They seem to kind of beat that into you, part of the engineering training. So, but it's a tough balance, right? Especially talking to investors who may or may not be familiar or intimately familiar with the challenges of bringing products like this into the marketplace. It can be very tempting to to sort of add those layers of hype into it. So. But as we said before, I think those of us that have come back for a second round or that are entering again, I think many of us have been chastened by the lessons of the past, and I think are being a little more intentional in how we're going about this. And I agree with Zach, right? The proof is always in demonstrating it. So it's one thing to talk about, it's something else to actually deliver it or put it in a customer's hands. That changes the way the conversation goes.
Yeah, and I think there's a big piece around the credibility in the communications, because at the end of the day, your reputation is everything. A company's reputation is its greatest asset. And we do need to communicate better about the industry and about the technologies. And it's something that I always wonder about, because these are not things that very many people understand. And if something goes over your head, you're either going to think, wow, this is a sort of a mystical savior that's going to lift us out of all the world's problems, or you're going to fear it because you don't understand it. And I think that the media that we're often dealing with, not the specialized biotech media, but the more general tech or finance media, they very rarely have that level of understanding. And even if you try to understand things, it's going to get dumbed down at some level because the audience needs to understand it. And so that's a real communications challenge, I think, for you guys, to try to stay grounded and credible and honest about what you're doing, but make it understandable to a more general audience. How do you go about that?
Yeah, I think like Zach said, I think we do have the opportunity to change the world, and the trouble is the timelines are going to be longer than we would like, right? So I think we can change the food supply network, we can change materials, but it's going to take a decade or two longer than, it's not going to be next year or anything. We'll have initial successes, and so I think it's being measured and realistic about the timelines.
Do you guys agree with that timeline, 10, 20 years to start to really change systems thanks to biology?
Not to start to change, but to change the food supply and the material supply.
So, it's a big change. I agree with you. Is that realistic?
There's that Bill Gates quote that people overestimate what they accomplish in a year, but underestimate what they accomplish in a decade. I think that I agree it's not going to be next year, but if we can start to amass enough proof points, we'll start to also attract more capital and more talent to the sector, and hopefully it becomes a virtuous feedback loop whereby, like other phenomenons of the economy, it just becomes almost a self-fulfilling prophecy because it's so clearly the right thing to go do. And by the right thing to go do, I mean from even just a purely economic sense. If you look at the biggest companies on the stock exchange by market cap today, they're completely different, with the exception of Microsoft, than they were 15 years ago. Like the ExxonMobil is no longer there. So change does happen on the 10 to 15 year time scale. And I have high hopes that 10 or 15 years hence, synthetic biology companies will be amongst the top 10.
Yeah, and we've seen the technology advance, the tools, the instrumentations and methods, such as CRISPR, such as synthetic sequences, that's speeding up those timelines. So there's always, of course, potential for more disruptive technology that will speed up those time frames. But in the innovations that I see, it's still early stage, I guess. Companies are still trying to scale up and control animate systems to behave more on the productivity and yield level of inanimate systems. So it's still early, but the tools are developing.
I wanted to know, Martha, what the perspective is in the US. Is the US government favorable to biotech, and are there any sort of differences around synbio? Are you having to convince lawmakers that this is a good idea, or do they get it? Do they get it already?
Right. I think, in the U.S. is a very receptive, regulatory and government attitude towards biotechnology. There's been many initiatives in the past several years to promote the bioeconomy by this administration and the prior administration. So I think it's more receptive here by our government than some other parts of the world, frankly, and just hope to see that continue.
And I wanted to check in now with the companies, because that sounds like a very positive picture. The government is very receptive to the bioeconomy and biotechnology. Is that the same impression that you have really working on the ground in your companies, or do you have a different perspective on that?
From a regulatory point of view, I think I'd be inclined to agree, at least relative to other geographies. From a government support through fundamental grants and influx of cash into both training programs and universities, as well as research programs that can be the starting points for the next generation of companies. It's not what I wish it would be, I think, but I also expect that things will change once we have more demonstrations of utility, of success.
And is that research funding, or is that access to scale up facilities, and what does that look like?
A combination, yeah. I mean, we do a lot of contract manufacturing, and we look overseas for a lot of it for lack of available or flexible enough facilities in the United States, fermentation facilities in particular. So yes, there does need to be more infrastructure, more investment in some of the steps that happen downstream of the micro engineering as well.
I see a lot of US companies going to Europe to do the scale up and some of the manufacturing. Is it really the case that in the US you haven't got enough access to fermentation facilities? It sounds like a relatively simple thing to have as part of your infrastructure.
Yeah, no, that's been our experience as well, but we've had to go abroad for even moderate scale fermentation.
That's interesting.
Yep, and we've found the same. There just really are very few choices in the States. We've had much greater success abroad.
So what would it take for the US government to smooth that for you? Is it investment? Is it pilot facilities? I mean, what would that look like?
It's all the above. I mean, there are examples in Europe, right, of sort of these public-private partnerships where capital supports the infrastructure, but then it becomes this partnership, and it also serves to train the personnel to do it, to train people to be active in the bioeconomy.
And some of those are spin-outs of large chemical companies like DSM, for example, in the Netherlands.
Yeah, and that's a great way to get facilities, right? To get facilities very affordably, right? So when a company decides that they no longer want to use an asset, then with a little bit more capital investment, from say the government, then now you have a really good starting place for some type of, say a pilot or a demonstration scale facility. So I think that is an area where in the US, there could be more activity and more support.
And I think the government's starting to recognize that, Matt, because, I'm thinking about the DoD that is just announced and has been getting off the ground this year, the second Manufacturing Innovation Institute that's geared toward biomanufacturing. And one of the sector areas is pilot scale facilities and scaling up. So the DoD is starting to invest in that area, and, that's usually a big chunk of investment. So, as Zach said, it's going to take time, but hopefully that will change for the better here.
Well, that just sounds positive. If I listen to you guys, you're painting a very positive picture. So how come I still have that impression that there is a lot of hype in synbio? There's a certain amount of synbio Kool-Aid being drunk, and it doesn't sound like it's you guys doing it, but it certainly still seems like there is hype out there. and the mainstream or the science and tech press kind of gets sucked into that. Am I totally off here, or is that something that you're still seeing happening out there in the world, the SynBio world?
Yeah, no, it's still happening, but I think that there's wonderful stuff going on, and it's kind of uneven. Like I said, I think we need to somehow prioritize or sort of bring reality to some things. And I know, at the risk of being provocative, one example is, there's a lab that had this enzyme to degrade polyethylene terephthalate. So it was on the cover of major magazines saying we've solved the plastic problem. That kind of statement is just doesn't help at all, because it's disappointing to people when they realize, oh no, we haven't actually solved it. So.
Yes, that's a great example. Anybody got more examples? Feel free to share.
One should not mistake volume for progress. And so, I mean, yes, there are companies that are actively participating in a hype cycle, in my opinion, and self-promoting to the point of probably eventual letdown. And you happen to have on your panel today people who aren't taking that approach. And I have to admit, in the early days of Zymergen, we actually shunned the term synthetic biology, because back in 2013, when we were founded, and in the years following, it was so much associated with money losing that you didn't want to leave that taste in the mind of your investors. I mean, we focused on our business model and engineering biology and developing products. These days, SynBio is now back in vogue, and so we embrace the term again, but we do so judiciously, knowing that our fate is going to be determined not by the relative how the public views synthetic biology, but rather by the traction our products have in the market. So there could be a second synthetic biology bubble that bursts, and I honestly think Zymergen will withstand that, because we'll be held to a measure by our revenue growth and our market traction with the products we're launching. And so it's safe now for us to re-embrace the term.
What did you call it back then?
Oh, we came up with all sorts of kludgy names, and it's not even worth recounting them. But fundamentally, we just talked about engineering biology or working with biology.
It's more accessible to a general audience anyway. I mean, I don't think the general public would understand what synthetic biology is. Anyone else got some good terminology for synthetic biology when you're trying not to use it? Any other euphemisms?
Really?
How about just fermentation?
Yeah, that's a good
Right.
one.
Yeah.
And plants. I mean, that's what it's about.
Making materials from plants.
Right.
All right, well, just before I wrap up, I want to get your thoughts on a final thing, because I know that Bio has quite a lot of students involved in following the conference this year. And how do we make science cool again? This is what I want to ask you, get your perspective on, because you're all working in really interesting companies. You have very interesting roles. What would it take to make science cool again? And maybe it is cool again.
You mean it's not cool?
You mean it's not cool? Nobody told you, right?
I'm excited about it every day. Like, I mean, the crazy thing about it is that, over 30 years of my career, just the science has changed so dramatically, and it's been such a blast to be a part of it. And then, and we're working on really important world-saving problems. When there's a crisis, who do you turn to, right? It's science, right? So that's my opinion.
I think that's a great perspective. I'm coming at it from the point of view of, societal acceptance. There's a knowledge gap, there's an acceptance gap. And I think that in the biotech sector, we can probably do something to fill those gaps.
I think synthetic biology has something to offer the next generation in terms of appeal, in that it allows you to, it is an engineering discipline. I mean, we all agree that the definition of synthetic biology is applying engineering principles to biology. And so whereas a classic biologist basically dissects nature and tries to understand mechanism, what's working under the hood of biology, what you do in synthetic biology is you employ what is understood, or even through advanced techniques of machine learning, even pushing those boundaries, and make use of them for some societal good, for the development of some product to fulfill an unmet market need, for some sustainable solution. And I think the application of science, which is basically engineering, in biology has the potential to attract a whole separate set of creative individuals that might have been overlooked or passed over, or they might have passed over becoming a full-fledged biologist.
Right. Yeah.
I think it goes back to being able to put it in someone's hand. So just as in putting, you know, grams or kilograms or tons into a customer's hand or a potential customer's hand, I think if you look at the students, you know, with synthetic biology or metabolic engineering or making products and materials, now you have the opportunity to actually put, you know, thin films or, you know, other types of novel materials in a student's hands. It's something they can actually sort of sink their teeth into, if you will. So I think that has the potential to sort of, you know, change the design space, if you will, of the types of people that you might attract. So much like, you know, revolutionizing 3D printing, right? Everybody in their neighborhood can have a 3D printer now and print all the things they want. I think we're headed in that direction with biology and with metabolic engineering, where you can actually, you know, you can actually feel it and touch it and see the outcome of your work. You know, I think that's in the pharmaceutical world with biotech. You know, I think that can still happen, but it's not so direct, right? You're talking many years to develop a product and get clinical trials and get approval. So you can really materially help people, but it takes a very long time. You know, in this case, you know, I think we have the potential to do that in a much shorter period of time.
Yeah, and I think it takes leadership. And with that, I would like to thank all of our speakers, Zach, Martha, Jim, and Matt. Thanks for joining this panel on SynBio, Fact or Fiction.
Thanks, Kathryn.
Thank you.
Thank you, Kathryn.